Hello everyone, this is Ashwini from Cheenta.com. Today we have a very beautiful problem from the middle school math Olympiad program at Cheenta, which is from grade 8 to grade 6. But this particular problem and problem solving strategy is also useful for adults. Let's say you're preparing for IOQM, American math competitions, or ISI-CMI entrances. This is a very important and fundamental principle in problem solving, and we will learn that in this particular video. This is called the point symmetry strategy. Okay, so at the end of this particular video, I will also give you a challenge problem based on this strategy. So check that out. As usual, the best commenter will be invited to present at our YouTube channel, and there are also some awards for the best commenter in the month. So make sure to comment. All right. So let's start with the problem. So this is a game. The game is like this: that you have a 6x6 grid. That means there are 6 rows like this, and there are 6 columns. And you have dominoes. Dominoes means it's a 1x2 piece. So you can also put it horizontally and vertically. So if you put it vertically, it will look like this. So then it's like a 2x1. Okay, so it's a 1x2 or a 2x1 piece, and 2 players are playing a game. There is player A and player B. Now think about this game very carefully. I describe what this game is. Okay, what the player A does, he starts the game and he places a domino. So both of them have infinite supply of dominoes. Okay, so maybe he puts a domino in this particular place. So he can put the dominoes on the top of the grid so that they exactly fit. A box is on the top of a box. The player B comes along and puts another domino. So the player B is suppose the green player, and the player A is suppose the pink player. Okay, player A puts a domino, player B puts a domino, and they keep on playing. Now the rules are dominoes cannot overlap. So you cannot put, so for example, you cannot have B put a domino like this, because then the pink and the green domino would overlap, right? That's not allowed. So player A starts, the player A puts a domino, player B then comes along and puts another domino, and so on. Okay, so like so, they keep on putting the dominoes, and the first person who is unable to put any domino on the board, first person, let me write it in black, first person who fails to put a domino, on the board, loses the game. So I put a domino, you put a domino, I then again put a domino, you then again put a domino, and after a certain amount of time, there is no more space on the board to place any more dominoes. There is no more space on the board to place any more dominoes without overlapping, let's say. Then the person who is the last one to actually place a domino properly will win the game, and the first person, the other person who is unable to put any more domino on the board, loses the game. Okay, the question is, which player has a winning strategy? Which player has a winning strategy? Okay, and therein comes the point symmetry method, which is so beautiful. This is so beautiful. So what is the point symmetry method? And some of the kids in our middle school Math Olympiad program could actually think about this particular strategy. They could sort of discover this strategy inside the class, which is totally awesome, by the way. So you should definitely pause this video at this point and try to think and discover it on your own. Okay, so the point symmetry is find a point about which this board is symmetric. That means you can reflect pieces of that board about that point and you would get the board back itself. So I'll give you an example. In this particular circular disc, okay, maybe I can just use a regular circle. In this circular disc, the point of symmetry is the center O. Okay, and why is that? Because let's say if you put something here, you can reflect that about the center point here. So basically, reflect means connect O with P, just extend the straight line and reach a point P prime such that OP is equal to OP prime. So these two pieces are equal. This point P prime is the reflection of the point P about the center point O. Okay. Now, the most important point to understand is this, that if you reflect every point on this board about this center point, you will get the exact board back. You will get the board back. Okay. So you could reflect about some other point, let's say a point like here, maybe O prime. If you do that reflection, then here is a challenge question. Challenge 1. Then can you tell me, if you reflect about this point, what would happen to this board? If you reflect about this point, what would happen to this board? That means if you reflect about O prime every point on the board, what kind of shape will you get, and what is that relationship of that shape with this original circular board? Okay. Okay, maybe you may already understand that. If you can, please put a comment in the comment section. Let me know what you think. So, this point of symmetry, of course, the center point, you reflect everything, you get the board back. The same thing is true about this board of 6x6 grid. The center point is this one. Here, let's call this point O. And about the point O, you can reflect stuff. Okay? So if you do that, you actually get a winning strategy. Let me show you how. Suppose I'm the first player, the pink player comes along and puts this particular domino. Okay? So what the green player would do, the next player, is that the person would just reflect this pink domino to here. So let me just erase this one. Oops, sorry. So I'll just go ahead and erase this and just make sure to get the entire thing back. Okay. So the reflection of this point is this one, reflection of this point is this one, reflection of this point is this one, reflection of this point is this one. So you basically get a domino like this. So you get a domino that looks like this. And that place is empty because you're just starting out the game. So the pink player, wherever they put the domino, the player B would come along and put a domino at the point of reflection. That's a symmetry method that I'm describing to you. So I'm actually giving you a walkthrough through an example of such a game. Alright, so let's put another one. Let's say the pink player now comes along and put the domino here. what would you do? Well, you would put the reflection like so. Remember, this reflection is always empty. Nothing is there in the reflection, because if there was something here, then in the previous step there would have been something here, but that place was empty. That's why the pink player could draw it there. The only way the reflected place is occupied by a green domino, if in the previous step the original spot has been occupied by some pink domino. This is the critical part. I want you to carefully understand this. Why this green domino spot is empty is the core of this entire argument. This green domino spot is empty because in the previous, otherwise, it's a contradiction. Otherwise, in the previous step, the first player must have put something here. The only way a place is occupied if the previous spot, the reflected spot, is occupied by the pink player. So this is sometimes known as a recursive argument. Of course, in the middle school, we cannot really talk about recursion unless you are taking the computer science course at Cheenta, which does talk about recursion a little bit. But this is a very interesting scenario. Now let's keep on playing the game. You have to convince yourself that this will work. So let's say the player puts a domino here. Then the player B would put the domino here. And the player A comes along and puts a domino here. Player B would put the domino here. Oops, sorry. So he's just reflecting whatever he's putting. Okay, so let's say the player A puts a domino here. Like so. Okay. And player B would put a domino here. Options are shrinking. Maybe the player A puts a domino here. Then player B would put the domino here. The reflected spot is always empty. The reflected spot is always empty. Now the player A is almost out of our option. Maybe the player A puts a domino here. Then player B would put the domino in the reflected spot, which is here. And now the game is over. There is no other place for player A to put the domino. So basically player A loses the game. And this strategy would always work. Wherever the player A puts a domino, player B would go along and put a domino in the reflected spot. And every time the reflected spot would be empty, so the player B would be the last one to be able to put a domino without overlapping in the board. Okay? So think about that argument very carefully. You may have to do a little bit more example tracking to actually internalize what's going on. It's very important that you really see what's going on. Okay? That only you can do it. Just doodle with some examples and you will see the power of this point symmetry strategy. I mean, this is just one problem. There are many problems like this. So you can think about it, and if you can get an argument, so this is this challenge too, write down an argument. And I've already told you that, but I would like to see how you write mathematics. So write an argument explaining why the reflected spot is always empty. Okay? Why the reflected spot is always empty. Alright, so think about it, and I will see you in the next video. Keep on doing great mathematics, and if you want to join the new Math Olympiad, courses that are starting at Cheenta, or physics or computer science courses that are starting at Cheenta, check the link in the description. We have beautiful programs for the advanced mathematical contests. We focus solely on that. So I hope you will like it. And if you are an internal student, please make sure to attend the 5 days a week problem solving sessions. Most of our success in IUQM, ISI-CMI entrances, American math competitions, etc. are from the students who attend the 5 days of problem solving session every week, week after week, month after month, year after year. Consistency is the key. All right. Okay. I'll see you in the next one. Take care and bye.